All right, so chapter 2, we've got some proportional reasoning going on. So a lot of this should look familiar to you, but make sure to jot everything down anyway, including all the vocab and all the examples. So we're going to review some skills that we've used in the past when working with ratios and proportions. Let's recall some vocabulary first. What is a ratio? It's just a comparison of two numbers. So I have apples per basket, dollars per hour. I'm just comparing two units of measurement. Okay, a ratio can be written in fraction form. It can be written as A per B in this way. And it can also be written in words. So apples per basket, dollars per hour. So those are three different ways that ratios can be written. So we're going to take a look at an example of each of those. So if I say you were paid $28 for 3 hours of work, I could say $28 per, there's my fraction bar. That per is just where you put your fraction bar. $28 per 3 hours. So there's in fraction form, there's my ratio. I could say 5 pounds per $7.25. Let's take a look at that one for just a second. So actually, you know what? I'm going to go on to the next example. I'm going to get back to that one. It takes 4 hours to run 26 miles. So let's do this in word form. I'm actually going to flip it around because to me it makes more sense to say 26 miles, right, per 4 hours, because we're used to hearing miles per hour, right? That's a speed. So, whoops, it's not per 1 hour. It's per 4 hours. So that's why I flipped it around, because again, we're used to hearing miles per hour. So to me, it makes more sense to say it in that way. Now, like I said, I'm going to get back to that second one. So does it make more sense to say 5 pounds per $7.25? Or does it make more sense to say $7.25 per 5 pounds? Well, when you go to the store, you're going to pay per pound, right? So did you hear that? Per pound. So usually when you're dealing with money, that money is going to come first. It's going to go in the numerator of a fraction. It's going to come first in this form. And in words, your money will come first before the per. So just be aware of that when it comes to money ratios and proportions. So again, a little bit more review with vocabulary. We've talked about rational numbers before. A rational number is just anything that can be written as a fraction. I'm going to go through some of these and then we'll go through some examples. A rational number can be an integer. It can be a repeating or terminating decimal. And here's some of your examples. So when I say it can be written in fraction form, the number 12 can be written as 12 over 1, right? That can be written in fraction form. 1/2, right? That's fraction form. That's also a rational number. -6, that's going to be what we call an integer. 6 is a whole number. The opposite of that is -6. That's an integer. All right, so integers are rational numbers. 3.2, that's a terminating decimal. So that's also a rational number. Terminating decimal is one where the decimal ends. There's no, it doesn't continue on and on and on, right? 5.7, also a terminating decimal. 1/2, we already said. The square root of 16. If I simplify that, the square root of 16 is 4, because 4 times 4 is indeed 16. I'm going to give you one more, because we also said repeating decimals, right? A repeating decimal, if you don't remember what I mean by that, would be something like 3.33 repeating, right? So there's a pattern after the decimal point. That's also a rational number, because I can write that as 3 1/3. Right? There's a fraction that goes along with that. So that's also rational. Here's some non-examples of rational numbers. 3.14159 and so on. That's pi, right? There's our symbol for pi. Square root of 17. If you try to plug that into your calculator and hit enter, what do you see? All of these numbers are going to be decimals that have no pattern and they go on and on. So those are not rational numbers. In other words, they're called irrational numbers. I'm not going to worry so much about irrational numbers right now. All right, a little bit more vocab for us. Remember what a proportion is. Proportion is just simply two, and I'm going to add to that, two or more. It could be more than two ratios, but we're going to stick with two. Two or more ratios that are set equal to each other. And again, they can be written in various ways. So A per B equals C per D, or in fraction form right here, A per B equals C per D. It's easier when we look at some examples of that. So some things about proportions just to be aware of. Take your time setting your proportion up. If you go too fast, you're going to put things in different places than where they belong, and that's going to change your proportion. Comparisons have to be the same on each side. So for example, if we have a weight per serving, so 10 grams per one serving, on the other side, I want the weight to be on the top as well. So if you look at that, weight matches up with weight, serving matches up with serving. We don't want to do something like this. Weight per serving equals serving per weight. We don't want to flip things around. Again, that changes our proportion. So let's look at some examples. All right, so the ADA, or the American Disabilities Association, requirement for accessibility, in other words, where you put ramps so people in wheelchairs can get up and down out of the entries. The requirement for those ramps for buildings is 1 to 12. In other words, if a ramp is, like if you look right here, if that ramp is 12 inches off the ground, then it has to start, oh, I'm sorry, I said that the wrong way around. Let me edit that. If that ramp is, say, 1 foot off the ground, right here, so this is 1 foot high, it needs to start 12 feet away from the building. So that's what that ratio means. So 1 foot high means you have to start 12 feet away from the building. Okay, so we have 1 per 12. So if an entrance is 16 inches off the ground, okay, so where does that 16 inches belong? So again, this is 1 foot off the ground, 12 feet away. So 16 inches off the ground matches up with the 1. 1 foot off the ground, 16 inches off the ground. So what am I looking for? I'm looking for that denominator. All right, so if I set up my proportion the right way, so this is, again, 1 is off the ground, then the 16 is also off the ground. Notice those are both in my denominator, right? The 16 again is off the ground. And my denominator then is feet away from the building. Both of those denominators should match up, feet away from the building. So if I take a look at this, how am I going to, how am I going to solve this proportion? So what can we do? Here's, I think, the easiest way to take a look at this one. So if I do 1 times 16, if I think of these as fractions, I just want to create an equivalent fraction. So if I multiply that numerator by 16, I'm also going to want to multiply my denominator by 16, right? So if I take my calculator here and I do 12 times 16, I'm going to get 192 inches. So I need to start 192 inches away from the building. As much as that seems like a lot, remember this is inches, so 192 is not that much. Let's look at another one. Caterer just found out that the number of people attending an event increases from 45 to 130. The plan was to prepare 35 pounds of pasta. How many pounds do we need now? So let's go ahead and set up our first ratio. So let's look at the number of people. So the original number of people was 45. How many pounds were they going to use for 45 people? So it looks like they were going to originally try to prepare